Alright, boys and girls, welcome to our second video lesson in Chapter 4, our lesson on congruent triangles and their corresponding parts. Here we go, let's do this now. First, let's start with a definition of congruent polygons. Congruent polygons or shapes are two shapes that have both the same size and the same shape. The symbol for congruent, you already know, is that, and that is because this part right here means same shape, and this part down here, the equal sign, means same size. These fishies are all congruent figures because they are the same shape and the same size. Well, these guys over here, they are the same shape, but they are not the same size, so therefore they are not congruent. When we name congruent pieces, you must match up. You must match up the corresponding parts. So as we look right here in these two triangles, angle A, it does correspond to angle H. Angle B, it corresponds to angle J. Angle C, it corresponds to angle K. AB, it corresponds to, I'm looking here, to HJ. BC, it corresponds to JK. And AC, it corresponds to KH. So when we write these triangles, you must write down in order. Triangle ABC is congruent to triangle. I'm going to write it down below here so we can see what is corresponding to A. Well, that will be H. What corresponds to B, that is J, and what corresponds to C, that would be K. So triangle ABC is congruent to triangle HJK. That's fine. As we look down here, this is an okay way, a second way to write down this statement, because angle B, it corresponds to J, angle C, it corresponds to K, and angle A, it corresponds to H. But this is not okay because we're not writing down our parts, their corresponding parts, in the same order in each of our triangles. So here we go, A is to H, that's good, but B goes with J, so we see that these are not congruent triangles written this way. All right, let's talk about, first of all, how we write down the names of polygons. If I look right here, if I want to name a quadrilateral, okay, so I'm going to write this down right here. All I have to do is start at any point, any angle, and go either clockwise or counterclockwise around the polygon. So if I wanted to start with S, this could be triangle SPQR, or it could be quadrilateral SRQP. But I could not write this down as quadrilateral SQPR because I'm jumping from S to Q back to P and then over to R. Okay, looking down right here, a little guided practice. What corresponds to angle A? Well, it would be W. What corresponds to angle B? It would be X. What corresponds to C? It is angle Y. What corresponds to D? It is angle Z. So if I wanted to write this down, I would say that quadrilateral ABCD is congruent to quadrilateral WXYZ, not because they're alphabetical, but because those are the corresponding parts in the same order. A goes with W, B goes with X, C goes with Y, and D goes with Z. Why don't you guys write down a congruent statement for the triangle right here? I'm going to write triangle LKJ is congruent to what triangle? Stop the tape and give it a go. Okay, you should have written down that triangle LKJ is congruent to triangle QMP because L corresponds with Q, K corresponds with M, and J corresponds with P. Let's solve for X and Y in this problem right here. Let's first start to find angle X. We can see that angle X is the measure of angle T, and T, it corresponds with angle R. So if we can find out the measure of angle R, then we're all set. I know that angle R must equal 12 because 78 plus 90 is plus R is equal to 180, so R is 12, therefore X is equal to 12. Okay, if we're looking right here, I need to find RS. RS, it corresponds with VT, so I know that 2y minus 1 is equal to 24. I'm going to add the 1 to both sides. 2y is equal to 25, divide by 2, divide by 2, y is equal to 12.5. Alrighty? A third theorem here in this chapter, the no-choice theorem, one of my favorites in all of Geo. What it says is that if two angles of a triangle are congruent to two angles of a second triangle, then by no choice, the third angles of each of the triangles must also be equal. In other words, if angle C is equal to K and B is equal to J, then A must equal L by the no choice theorem. So if two angles are equal to each other, so angles B and J and C and K, then angle A must be congruent to angle L by the no choice theorem. Alright, CPCTC stands for corresponding parts of congruent triangles are congruent. CPCTC. We use that in proofs to show that parts are equal. So, and again, we'll do this in class, but if triangle WAY is congruent to triangle box, then angle W must be congruent to angle B because those are the corresponding angles. AY must be congruent to OX because those are the corresponding sides. Angle X must be congruent to angle Y because those are corresponding angles, etc. Please note that we use CPCTC in proofs only after we've proven the triangles congruent. Don't use CPC to prove triangles congruent. You guys try this slide right now. Write down a congruent statement for triangle ABC and triangle BAC. Okay, we got triangle ABC is congruent to triangle YZX because those are my corresponding parts in the correct order. And triangle BAC is congruent to triangle ZYX because those are also the same corresponding parts, but just in a different order. Okay, so we look at this right here. We got triangle MON is going to be congruent to triangle, let's look here. So M corresponds with R. I'm looking right down here at the bottom. M corresponds with R. So that's R. O corresponds with S because those are the third points listed. And N corresponds to T. So MON is congruent to triangle RST. Angle T would correspond to angle N, because those are the first points listed, and ON, that's going from 3 to 1, would be congruent to segment ST. Same thing back to here, just like we did here in ON. Alrighty? Hey, have a great day, folks. We'll see you mañana.